All right, you ready?
Oh.
I think about 5 minutes is up.
Yeah.
Okay.
Oh, really?
So, Ralph, do you want to help with an introduction of Doyle? Would you like to introduce yourself?
This is Doyle.
Ready.
This is Doyle Pittman.
Mr. Miss Pittman.
If you didn't read his bio, Doyle got his degree in
atmospheric science.
atmospheric science at Purdue. He worked for TVA as a meteorologist for a number of years until he retired. And we're in our life group together. I didn't realize he was a meteorologist until we had an outing for the
Try to
church.
keep it quiet.
And some of the guys were talking about some of the things that Doyle's done, and he was a meteorologist. So the next day I said, hey, would you do a program for us on meteorology and try to talk about what to look for in clear skies, so like we have tonight.
That's awesome.
So anyway, Doyle's here.
All right. Thank you, Ralph. Glad to be here with you. Appreciate the opportunity. When I started thinking about this, I kind of took me back to my younger days when I grew up on a farm in rural Indiana.
Me too.
All right.
Pittsburgh.
Okay. Bremen.
Okay. But it's north, right?
Yeah, it's north.
Yep. I've been through Berlin, yeah.
So living on the farm, very little light pollution. You know, we were out in sticks pretty much.
Yeah.
So have fond memories of going out in the backyard and viewing the sky. But all I knew at that point was, and still, is the Milky Way and the Big Dipper and the Little Dipper. Good memories there. And since then, I guess I view more of the clouds than the sky over my career. So whether or not that's a good thing, I don't know. Okay, that went right over your head. My daughter said I had to do something with whether or not, so I tried. So, talk a little bit about what I did at TVA. When I tell someone that I worked as a meteorologist at TVA, the first question is, well, why does TVA need a meteorologist? So, therefore, this slide lists some items. The first one is temperature forecast for the power load forecast that TVA does every day to make sure they have enough power to keep the lights on, which is a good thing.
Yeah.
So back in the day, the rule of thumb was on the max temperature forecast, for every degree you're off, that makes a difference of about 500 megawatts. And our peak load back then was like in the 20,000. I think it's in the 30,000 now. So
37.
okay, thank you.
What does Ralph know?
Well, fact checkers. So those forecasts are important. And then for precipitation forecasts, it's an important thing to have meteorological forecasts for the reservoir levels. If they know there's a big rain coming, they can open the floodgates and get the water to the right reservoirs to minimize the flooding. So there's a couple examples. Myself, I worked with the nuclear plants, so that really gets the question, why does TVA need a meteorologist for nuclear? So I thought, since I don't get a chance to talk about this much anymore, I thought I would hopefully not bore you all, but talk a little bit about what I did with the nuclear plant. And I worked with Tom on some of this stuff, so he can correct me when I'm wrong. But from a routine standpoint, we collect the meteorological data and analyze it and apply it for the 3 nuclear plants that TVA has: Brownsburg, Sequoia near here, and Watts Bar. And then we also supported the emergency preparedness program through participation in the Central Emergency Control Center. From the routine standpoint, we're required to continuously operate our weather towers that we have, and then the weather data is displayed in the plant control room. One of the things that's used for is quarterly dose calculations from routine releases. A lot of people don't know, maybe you don't want to know, but there are routine releases, very small, from the nuclear plants. So we use the weather data, the actual release information, and an atmospheric model to calculate what those doses are at the nearest residences in each of the 22.5 degree sectors around the plant. And so TVA has to meet stringent Nuclear Regulatory Commission limits for that. And then they also have monitors located around the plants. It's kind of ground truth on what we're estimating the doses were. And then we do forecasts for special conditions, high winds, fog, and severe weather. On the emergency side, this is where I work with Tom. Each of the plants has an annual drill or exercise, depending on the level of it. And then we support actual events. So we provide forecasts for those events. We have access to the real-time weather data. And again, those are put into dispersion models to predict the direction and dose levels from those. So we use the wind direction, wind speed, and temperature and precipitation for those. So you might ask, well, did you ever have to respond to an actual emergency? And I was involved in 2 of those. Fortunately, neither one of those was an actual release from the nuclear plant. But then, you remember in 2011, we just had the 25th anniversary of the tornado outbreak that hit Ringgold and Harrison and then in North Alabama. So there was some pretty significant impacts to the power grid, especially in northern Alabama. So the emergency center was activated, and meteorologist's job, they wanted to know if there were any more tornadoes coming, and if they were headed toward a nuclear plant or toward the emergency center in downtown Chattanooga. So we were monitoring the weather on that. Interesting fact on that, I think it's been changed since then, but the emergency center was located on the 6th floor of the office complex. And every time there was a tornado warning for Hamilton County, they had to relocate to the basement. So we were going up and down and up and down. So I finally convinced the director that we could tell more accurately where the severe weather was, that we didn't have to relocate every time. So I found out later that the radar in High Top, Alabama had been knocked out, so I was probably more confident on that than I should have been. It worked out okay. And then the other event was related to Watts Bar. It was a unique location there where we had a steam plant, a hydro plant, and a nuclear plant all within close proximity. So they had a fire at the hydro plant control room. I think it was the control room. So we were activated because they were worried about the smoke from the fire going toward the control room at the Watts Bar nuclear plant and getting pulled in the ventilation system. So we had to do a forecast as to which direction the plume was going from the fire. So initially it was heading toward the nuclear plant, but there was a cold front about to go through, so our forecast was for it to change directions and go away, and thankfully that worked out okay. Talk a little bit more about the meteorological data for the plants. These have been in operation since the early 1970s, so that's a long time to keep something going. So we do maintenance on the tower and instruments, troubleshooting the data and validation of the data. And then we use that data into our modeling for the routine and emergency. So this is a picture of the weather tower at Sequoia. It's a 300-foot tower, so think about that, it's about the length of a football field. So turn that up, pretty tall, and it's got instruments at 3 levels. one near the top, middle, and then one at 33 feet. So it's the tower on the left. The picture on the right, there's a little tower next to the big one, and that collects dew point temperature. Had to do more maintenance on that because there's a mirror that's chilled down to the dew point. So they have to keep that mirror very clean. So they put it on a short tower so they could tip it over and clean it easily. So on the left is a close-up of the instrumentation at the 33-foot level. On the left is a wind speed and wind direction sensor, and on the right is a temperature sensor. And you might say, well, that doesn't look like your normal wind sensor where you got the cup spinning around. We used to have those, but they're a high maintenance item, and they don't work very well when there's sleet or snow. So TVA was the first nuclear plant to switch from those to an ultrasonic wind sensor. So it's got 3 prongs on it. I think it's every 5 seconds it puts out a sound, and then you can measure the Doppler shift in that signal and accurately predict the wind speed and wind direction.
So it doesn't have any moving parts. Then.
No moving parts, right? So it's a low maintenance item.
Drops maintenance right away.
Only issues we found with it was at Browns Ferry, there's a firing range that security uses fairly near the weather tower. So when they're out there firing off their
Interesting
guns,
target.
yeah, it can mess up the signal. And also in a thunderstorm, when you get a clap of thunder nearby, it can affect the data. But those are pretty minor. So that has worked well. The temperature sensor has a aspirator on it to pull the air across the temperature sensor so you don't get artificial heating of the air there. On the right is a precipitation gauge, rain gauge, and solar radiation. The rain gauge has the little metal, what do you want to call those? Things that hang down to break the wind, so you get a more accurate measure of the precipitation. And then the solar radiation is on the right of that. So over the years, I have spent a lot of time and learned a lot by looking at the weather data from these towers. So this is an example of the temperature from that. So the air temperature is on the left. We can do what we call a lapse rate, where we take the temperature difference between the levels and normalize that to 100 meters. And based on that, you can estimate what the stability, what the dispersion in the atmosphere is. And then we've got a solar radiation dew point reading, a dew point, and the rainfall. So in this particular case, you can see that there was quite a bit of rain in the morning, and the stability was around the D or E, which is a very neutral, not much change in height and the temperature. But then when the rain stopped, you can tell by the solar radiation, when the sun comes out and gets up to a clear sky, and then the dispersion parameter goes to an A, which is really good mixing of the atmosphere. So something y'all might be interested in when you're looking at the viewing.
Is that because the rain normalized the temperature going up and down?
Right. Push the right button. Okay, here's an example of the winds. Again, at 3 different levels. We do an arithmetic wind speed and a vector wind speed and vector wind direction. The vector gives you a better estimate of the actual transport if you're looking at a release. So probably more interesting than the table is the graph I've got here of the blue is top of the tower, red is middle, and black is the bottom. So I think this is the same day that we looked at the rainfall. So during the morning when we had the rain rolled through, there was quite a bit of variation in the wind speed and direction, and then it got more linear after that. But the point I wanted to make here is even in the lowest 300 feet of the atmosphere, you can see a pretty large difference in the wind speeds. So you can imagine when you're going on up to into space, you're going to see a lot more, but it even is evident near the surface.
It's a pretty good difference between the 91 meter height or speed and the 10 meter speed.
Yes, it is. It is. Okay, this is called a windrose. May not be pertinent to viewing the sky, but I'm not sure. You can tell me. We got the 22.5 degree sectors, 16 of them, and this shows the wind direction by quarter. That's from Sequoia. So the predominant directions here are north-northeast and south-southwest. Anybody have an idea why that is true at Sequoia?
Prevailing wind from Birmingham.
No.
Mountains?
Prevailing wind at Chattanooga at the airport is from the south-southeast.
On the river?
Well, in the ridges.
Yeah.
You've got Walden Ridge on the north side and Big Ridge on the south side. So it has yeah, it has a very dramatic effect on the wind flow. And we moved to the 5 miles from Sequoia in 2000. And when my wife and I would walk, we noticed the wind was either in our face one way and not blowing behind us on the other. So it finally hit me. So, we're getting the valley effect on that. It's going following the road there. So, thought that was an interesting thing. But something to keep in mind wherever you're viewing, that you might have terrain impacts that could possibly increase the wind speed and maybe the turbulence. Okay, when Ralph asked me to do this presentation, I thought, well, this should be pretty straightforward, you know. So I got on Amazon and looked for articles about astronomy and weather. There's a lot on astronomy and there's a lot on weather, but there was nothing about weather and astronomy. So I'm scratching my head looking, maybe it's not going to be as easy as I thought. So Ralph helped me out with some articles he printed off for me to give me some education as to what factors are important, what weather considerations you have for viewing the sky. So I made an attempt here to list several. So in relation to what we just talked about, we got the wind speed change with height and the temperature change with height, and then fog and atmospheric pressure trend. We could probably add some other items to that list, but that's what I've seen so far. So we're getting into the summer season. So to me, that's a boring season weather-wise. One, you don't have many cold fronts go through. Jet stream is usually not that close to us, and the atmospheric pressure doesn't change much. You know, I check my barometer every morning, see if there's been much change. In the summer, it hardly ever moves. So those are a little bit harder things to use, I think, in the summertime, probably. I looked at the astrospheric application that many of you use, I think, which is a very nice product. I just listed some facts here to think about on using that. It's based on the Canadian Regional deterministic precipitation system model. So you've got one model to draw from. It includes the cloud cover, transparency, and seeing conditions, among other things, and it's computer generated. So I'm going to switch gears and talk about National Weather Service considerations. That's primarily what I look at for my weather information. I don't watch the weatherman on TV much, and I don't usually use other applications. But I guess part of it is when I graduated, I always wanted to work for the National Weather Service, and unfortunately, they weren't hiring at the time. Fortunately, TVA was. So. But some things to consider there. There's a 24/7 staff at Morristown, Tennessee, that covers our area. So we're kind of on the western end of their forecast area, going up into eastern Tennessee. So they have a lot of familiarity with the Tennessee Valley here. It's a free service. They use all the computer models. I've listed 3 of them here, which the first one is the European, GFS is the Global Forecast System, and NAM is the North American Mesoscale System. So they look at all those models, and their forecasts can be a blend of those, or they might pick one of those. So you get some judgment in there as to which model is doing the best. And when you're several days out, there could be a widespread in what they're forecasting. And then as you get within 2 days or 1 day, they look for kind of a consensus of the models and go with that. And they also do I'm trying to think what they call it now, ensemble, where it takes all of the models and does kind of an average of those. So sometimes that can be helpful. And they're talked about AI earlier. They also have some forecasting models for AI that they're starting to use, which is based totally on historical data, not physics like the other models. So, but the nice thing about the AI is it runs very quickly. So there'll probably be more and more of that factored in to their forecast. And then the National Weather Service has links to a lot of additional information. So what I'd like to do now is point out some of the products that are available from the National Weather Service that y'all might want to use to supplement your information forecasts you get off of Astrotheories and the other tools you have. So I've done a quick list here of what we're going to demonstrate. So I will just go through those. Pushing the wrong button, sorry. I have used an app called nwsnow.net for quite a while, which pulls the data from the National Weather Service to use on their app. So it was a handy thing to use. At the top, you can pick your location. You can have several locations marked to cycle through, and then it gives the current conditions, and then you have access to more information. So that was a good thing on my phone. National Weather Service does not have an app. You can use it on your phone. You can go to their website and get information, but I like to have something to have on your phone. And the reason for that is I was on a committee years ago that looked at public versus private forecasting and access to data. So National Weather Service is very sensitive about not wanting to compete with the private sector. So I suspect that is why they don't have their own app. but I found a way to get to it anyway. I don't know if my phone's getting so old or what, but I couldn't update this NWS Now app anymore. It wouldn't download it. So I accidentally, I don't know, it's an accident. I tapped right here to see what would happen. Lo and behold, it took me to the National Weather Service page. How about that? So that's how I get, if I'm not on my laptop, on my phone, that's how I get to the National Weather Service data. So I'm going to use that backdrop to illustrate how you can get to these different products. And I've got a list of the websites that Kevin has copied off and made available to y'all. So you don't have to write everything down here. But how many of you are familiar with the National Weather Service display? Okay, a few. All right. So this is the basic page. Since I had my app set on Hickson, it took me to the Morristown, Tennessee forecast and displays the data from Chattanooga level field. So you've got your basic weather data near the top and then forecast information below that. One thing I want to point out, there's a visibility on here, which suspects, it says 10 miles. Probably 90% of the time it's going to say 10 miles visibility because that's the maximum of the visibility sensor. Even though your visibility might be 40 miles, which doesn't happen too often. But it won't be beyond 10 miles, so something to keep in mind. So that's the top part of the National Weather Service homepage. And then on the bottom you have your narrative forecast and some other links. So the first one I'm going to highlight, the arrow is pointing to the hour. Can't read on mine. I can't read on that.
Hourly weather forecast.
Hourly weather forecast, yes. So if you click on that, if I go the right way, it'll show an hourly weather graph. So this kind of looks similar to the astrophysics output.
This is fairly recent.
Yeah, this is from May 9th. So it has you can also get this tabular, but I like to look at the graph more. It's got the temperature and dew point at the top. It does 2 day segments, so you can actually go out to the 5th and 6th days if you want to. And then it has the wind speed and direction forecast by hour. The barbs, the little flags show the direction the wind is blowing from. And then the number of barbs and size of the barbs tells you how fast the wind speed is. And then the next part has the relative humidity, cloud cover, and precipitation. And at the bottom, it's got in green, it's got the rainfall forecast with the digital amount, and below that is the thunderstorm probability. So for kicks, I pulled out the forecast for today, 5 days ago. And it was actually pretty good. It shows 0% chance of precip tonight and clear skies. And as the temperature cools, it's got the humidity getting higher and higher, close to the dew point. Initially, I thought you all were going to be doing some viewing tonight, so I thought we could see how accurate this came out, but you don't get to do that, I guess.
Well, how often is that updated during the day? Because it bit me last Saturday. I'm asking.
At least twice a day. If something really changes, they'll update it. But it's usually just around 2 p.m. and 2 a.m.
Okay.
Yeah.
2 p.m. got me.
So at the top of this page, you have a list of options you can pick on what you want to display. So you can add fog, pressure, visibility, some of those parameters that might be useful to you. Okay, go back to the main page. To the left of that, there's an item called forecast discussion. So this is an example of it. You probably can't read it. So the forecaster at Morristown, again, typically twice a day, they will update this. It gives their discussion, why they're forecasting what they are, what their confidence in it is, and where they have concerns about how good it's going to be. It can get somewhat technical sometimes, but most of the time it's pretty easy reading. They have terms highlighted in blue that you can click on and get a definition if you're not sure what that item means. But sometimes it's good to get an idea of why they're forecasting what they're forecasting, especially in the wintertime. I get tired of them saying there's a lot of uncertainty in the forecast. I guess to cover themselves. And like I mentioned earlier, as the time gets closer, their confidence is going to go up. But typically, within 5 days, you should be getting a fairly good forecast, a pretty accurate forecast. At the bottom of that is the aviation forecast, which is updated more frequently. And the reason I like this and why I think it might be useful to you all is because they talk about cloud cover a lot. So you want VFR conditions for visual flight rules, right? You could say visual viewing conditions. So if you find out when they're talking about VFR for visual, that means there aren't going to be any clouds. And then if there's more clouds, they might do a modified visual or instrumented if it's overcast. So, and they give information on here as to when they think clouds will clear out or when it will cloud up. Like I said, this is at the bottom of the forecast discussion. There's also another thing you can click on that takes you to the aviation forecast directly. Okay, if we go back to the home page there for Morristown, if you click on the Morristown, Tennessee, it takes you to a regional information page. Where they'll have some further discussion in a little simpler terms than what's in the forecast discussion. But they'll put items on there for the next few days that they think are of interest. But at the bottom of that page, there's radar information, satellite information, and weather maps with frontal information on it. So the top left is the Knoxville radar, and the next one over is the Huntsville radar, which is typically what you're going to look at for Chattanooga. So you can click on that and get an image and a loop of what the radar is doing. And, similarly, on the satellite. Click on that, you can get a loop. From what I saw, probably the most pertinent satellite view for viewing the sky is what they call band 11. So you can look down the different options. that they have there and click on band 11, which gives the cloud top temperature infrared, so you can get it day or night. So the warmer the cloud tops, the thicker the clouds are. And then if you click on the weather map here where the arrow is, they have forecast frontal positions for the next 7 days. So if you want to know how close the cold front is, how it might affect your viewing, you can look at that. You can also get the current weather map from this page also. And it shows the rainfall, severe weather, that kind of information also. Okay. Just above that, there's a list of acronyms where the arrow is pointing that you can use to get to other sites, like the space weather website is SWPC, the severe storms is SPC, National Hurricane Center is NHC. So it's a quick way to get to other things you might be interested in looking at. The NCO is where you can go to get forecast weather maps. And you use on that. And that's from the National Center Environmental Prediction Central Operations. And if you go there, you look under models and model analysis and guidance, you can see the different computer runs for the different forecast models. Okay, now I'm going to jump out of the National Weather Service site for the last examples here. Things I couldn't find on the National Weather Service pages that might be interesting to you are the jet location and the jet stream location and the profile of the atmosphere. So this is a site from the National Center for Application Research and the Research Applications Lab. Twice a day there are weather balloons set up at various locations across the United States called Raywindsons. And you can get to that. The nearest site to us is Nashville, which is where I've got the arrow there, and Atlanta. So Nashville is BNA and Atlanta is FFC. And if you click on that, it shows you this plot, which is called a skew T diagram. This also takes me back because in college we had to plot these by hand using the logarithms on data. Thank God we don't have to do that anymore. But there's a lot of information on this. A lot of it you probably don't care about, but wanted to show you it was there. The red line is the temperature profile from the surface up to 100 millibars, which is probably around 40,000 feet. The jet stream is usually around 300 millibars. And then, so you got the red for the temperature and the green is the dew point. Steeper the temperature plot is, going from right to left, the more unstable the atmosphere is. So if you think back to that weather data I showed you earlier from Sequoia, this would be the A, B, and C if it was a steep one, probably. So you can get an idea of how much vertical motion there's going to be. And then you can also tell how humid the atmosphere is at the different levels. This day is relatively dry. You see a pretty good spread between the two charts. Another thing of interest is near the surface, there's an inversion, which means the temperature increases with height. So there'll be very little dispersion going on in there. If there's smoke in the air or haze, it's going to be trapped in that inversion there. And then on the right is the wind speed and wind direction all the way up vertically through the. So you can see how strong the winds are aloft and how much change there is with height, or what we call shear, which might result in more turbulence. There's a LCL over here, which is the lifting condensation level, where if the air rises, that's the height it will get to when clouds form. And then CCL is the convective condensation level, which would be if you had air rising there, you'd have more likely to have thunderstorms or precipitation. So they call it a skew T because it's a log plot, and the temperature, constant temperatures. Let me get the right one here. There's so many to choose from. Are skewed. As you go up, it's not down. So that's what we call a skew T. A lot more information on there, but I'm not gonna.
Is that Is that corner plot the actual is the movement of the balloon as it's rising? The top right, the bullseye diagram.
That's a good question. I'm not sure. It could well be because it's moving with the airflow. So
It looks like a deviation plot from like above, like as it's moving and.
Yeah, could very well be. I have to check on that. I thought it was something else, but what you said makes more sense.
I don't know. I'm just
I'm not sure. Okay, and if I back up to this one, the other option I have here is to get the approximate jet stream, which you go to the 300 millibar, including contours link. And this shows the wind flow at the 300 millibar, or about 30,000 feet level. And the higher wind speeds are indicated by the magenta pink lines there. So the one on the left is from April 23rd, and the one on the right is for May 5th.
If we were looking at one of those, which one of those is better for us? So,
I was just going to ask you that.
Yeah.
Anybody have an idea? Good job.
I would say the one on the left.
Yes.
Yeah.
You want to
Less turbulence over the.
you want to be away from the jet stream, because that's going to, I think they say within 200 miles of the jet stream, you're going to have increased turbulence. So
I didn't realize it's split apart so much.
yeah,
does that only affect?
Yeah.
Does that only affect like the stability of the atmosphere? Does that have any play in like the clouds that come across also, or is that temperature related?
it'll affect the speed of the clouds, but it's primarily the wind speed and direction at that level. Yeah. The northern one, there's typically two jet streams near us. The north one is the polar jet, and the southern one, I should point this out, that's the polar jet, and this is the subtropical jet.
So the one on the left, the stream that's coming and going up like in Colorado,
Right.
is that the southern?
Now, southern is displaced.
Yeah,
north
there's
to
a
the
piece,
south.
if you go over
down.
to, if you go further to the left, it looks like there's a part of the polar that went down to the,
New Mexico or Barnard.
Yeah,
yeah.
yeah. So if you hear the weatherman talk about ridges and troughs,
Mhm.
this would be the ridge and this would be the trough. So your low pressure system will be following the jet stream up into Canada. And then on the right, you've got at 300 millibars, the winds are like 75 miles an hour, so it's pretty strong there.
You say it's at 300 millibars, but plus or minus what? I mean, it's obviously not 301 to 299. You know?
It depends on the temperature of the atmosphere, where it's going to be. But they actually calculate this at that pressure level.
You said exactly that
Yes,
pressure.
yeah. And as accurate as they can get. I don't know how accurate they are on that. But yeah, it would be at that level. So like I said, in the summertime, probably not going to be that much help because the jet stream is usually going to be, the polar is going to be way up into Canada, and the subtropical is rather weak. But it'd be a good thing to look at. Okay, so this is a list that Kevin got of the websites he's going to post. What do you do? Look at those if you would like.
Yeah, I was just gonna say, really, it's gonna be our group's IO and our Discord.
Okay.
I'll put them both as announcements.
Okay. So the last comment I'll make is, I'm going to quote Psalms 19:1, which says, "The heavens declare the glory of God." So, so what questions do you
What
have?
happens to the weather balloons after they go up?
They'll eventually pop and come
Pop.
back down.
Oh.
So the instrument cluster will fall?
Right. And if
Right over
someone
your house.
finds those, it has an address in it, you can
Please
send it
return
back and they can recycle it, yeah. It sounds pretty archaic, but it's a very effective way to,
There's no parachute or anything on it, it just falls?
Yeah.
It's like a air data computer that's nice solid box that
yeah.
can sustain it.
Yeah.
So that map you had on earlier, you had B&A is the one you were referencing. All the other that's where all the other places across the U.S. are putting up balloons to
Yes.
generate that map,
Yes.
right?
Yeah.
Well, weather balloons fly over.
Yeah.
I just didn't realize they were still.
Kevin's gonna go hunting for weather balloon
No.
cases.
But I just didn't know they were using weather balloons to that effect
Yeah.
still.
Yeah.
Um,
And when the Chattanooga office was still staffed, they would send some up, not every day, but, when there's severe weather possibility or something. they would send one.
On your diagram with the inversion layer and the squiggly lines, that one,
Yes.
is that top also an inversion layer that traps
Yes.
like dust and stuff up high in the atmosphere?
Could be, yeah.
So if it doesn't flip back over, we'd have less likely to have high altitude particulates.
Good point.
So
And,
it's question mark.
and they, you remember with the troposphere, their estimate of the troposphere is at,
Is that an altitude number, then?
yeah, that's a metric, so that'd be 11.9 kilometers.
So what about the smoke from forest fires?
That will impact your visibility and your haze.
Is there predictions for that sort of thing, or is it?
Not really that I've seen.
Okay.
Yeah.
So if there was smoke from regional fires or whatnot, it's likely to get trapped in that first inversion layer. Down, the first
Yes.
place
Yes.
where the temperature's inverted, or at the top. But
Yeah.
in that middle section, it's less likely to get trapped in there.
It should get dispersed more and be less visible there, yeah.
And then those two evaporative and condensative, the cloud layer, is that the top and the bottom of the clouds?
No. It'd be the bottom of the clouds, and then the CCL would be more like your puffy white clouds. It might turn
See how on the bottom of the thunderclouds?
Yeah.
And so above that second one is kind of where rain would come into play.
Right. Yeah. And usually the haze and the smoke will be in the forecast discussion. They'll make comment about that, or in the forecast itself.
And differing wind shear at differing altitudes decreases the stability of the air, so it wobbles more like this if there's winds blowing at different speeds.
Yes. In different directions. Yeah. Here you're starting off with winds from the southwest, and it does go northerly for a while, but then it goes back. So
If it was all going the same direction, even with differing speeds, we would see less rippling and turbulence. Okay.
yeah, I thought it was interesting that the jet stream is usually around 30,000 feet, and where do jets fly?
30,000 feet.
30,000 feet. That's no wonder there's turbulence, right?
What about the talk about the super El Nino? This year.
I'm not up to speed on that, but
They're saying in 1877 it was a couple times it was a super devastating.
Stay away from the coast.
El Nino's like a bubble of water off the coast, right, where the ocean comes up.
either abnormal warming or abnormal cold.
Higher.
Yeah, off the coast of South America, I think it is, right?
Does that affect how the jet stream moves, or does that do
It can.
something else, like
It
make
can.
another?
Yeah. Yeah.
They're
So
saying
the jet stream pretty much drives everything else, so, yeah. And there's a, CPC is the Climate Prediction Center, and they should have discussion of the El Nino, La Nina on that page.
But they're just saying that areas that are super wet could be really dry, and the areas that are really dry could be super wet. So.
Certainly drought.
We're certainly starting off dry.
Right, which is not good. Yeah,
No, it's
out
not.
west. Yeah.
Reservoirs are full also right
Good
now.
for the cows.
Coming from Florida, I used to see mostly on hurricane tracking, and they would show, a dozen plus paths for the hurricane. And it seemed that 3 or 4 of them would be getting it right, and the others, some of them were like way off. I mean, they had it making a left-hand turn and going to Cuba or something instead of Florida. And I always wondered why they didn't use some kind of historical cueing on it that says, okay, at this point in time, these models tend to be more accurate for a hurricane as it's coming across the ocean. Now, as it turns north, which they typically do, then these models would be more accurate. Now, they just throw all of them up there, and you have the spaghetti pattern. And
Spaghetti plot is what they
Yeah.
call it. Yeah, it's pretty confusing.
That produces maximum chaos.
yes,
Yeah.
maximum
They usually
chaos and maximum
have
fear.
a darker line in amongst those that shows where they really think it's going to go. But I guess that couple of things that shows you, if they're all over the place like that, that tells you, well, they don't really know.
They don't
where
know
it's
what
going. If they're concentrated, then their forecast is going to be.
I lived in Clearwater, and they had the storm coming up and was supposed to hit Clearwater and Tampa. A friend of mine heads over to Orlando. Instead, it came through Fort Myers, up to the center of the state, and right through Orlando. so he's stuck in a hotel.
One make a right turn, right?
May have been chasing him down.
With Paul, it could be.
And the AI has been used already on hurricanes.
I was thinking
Since it based
AI
on
would be a
historical.
perfect tool to start adding historical data into that to start making the
It
predictions.
used to be, back when I was in college, all your forecasts were based on what you remembered about different things, because the models weren't that good.
Yeah.
But now they rely a lot on the models.
On the aviation forecast, we were talking about instrument versus visual flight rules. How far out from the airport are they talking about? Is it just like the landing pattern for the airport, or is it a larger area?
That'll be for the full
So for
forecast.
Chattanooga, it would cover basically all the way down to Huntsville.
Well, we're on the west end, so it would be like Marion County to East Tennessee. They don't actually forecast for Alabama.
Okay. Do they do forecasts like per airport or per NWS region?
Both.
Okay.
Like they'll say, they think Chattanooga will be visual flight, but Knoxville might be like instrument flight rules. So they'll put in specific airports in their discussions sometimes.
But there's not a lot of, they're not making a whole lot of conversation about like until 10:30 p.m. or because the people who would use VFR aren't landing at 11 o'clock at night.
Not intentional.
Well, yeah. They come in pretty late, so. I guess you use visual at night.
You can.
Yeah, same
There's
as
enough
day,
lights.
actually.
Well, you wouldn't care about VFR if you had instruments and it was nighttime. You would just instrument land, probably.
I would think they prefer to use the visual, but I'm not a pilot, so I don't know. I'm speculating.
They're flying in all night. A lot of people.
Yeah.
Flying from about 4 o'clock to see the airport.
Yeah.
There's a lot of flights coming in. I don't know what they are all the time. But 4 o'clock in the morning is not unusual.
Chattanooga is not too bad, but they have a lot of regional airports up on Long Island. And between Kennedy, LaGuardia, Newark, the flight paths go all the way out, all the way across Long Island. So if you're flying a small plane, you're worrying always. So there is no good time.
Is there a place to find the predicted overnight low? Because a lot of times I notice the predictions I get are for the daily low, and you look at it and say, well, the daily low's at midnight, oftentimes, or it could be at 2 a.m. of the same day. That's already gone by, right? So it's not the future. So is there a place
This hourly weather forecast.
down right there? Okay.
Yeah, that's really nice.
Yeah, because your minimum temperature usually is just before sunrise,
Right.
right? So this shows a low of 55 at 6 a.m.
How does a dew point play into the clarity of the atmosphere? If we never dip below the dew point, how does that affect our?
Well, you can't. The temperature cannot go over the dew point. Once it gets to the dew point, it's either going to be raining or have fog. Right? Your instruments messed up. That was one of the things we looked at when it got below the dew point. Okay, something's wrong here. Clean the mirror. But the proximity of the dew point is going to tell you how much moisture is in the air. So if there's not much spread between the temperature and dew point, you know it's pretty humid.
You'd know what's the dew point.
You said you did predictions for
Yeah, everything I have
the
was
power
correct
company
2
and
weeks
for
ago.
the nuclear plant.
Was wet.
Did you do multi-day predictions, like you do tomorrow with such and such confidence, and then the day after tomorrow with less confidence, and the day after, or was it mostly just the day and the day after?
I think we did 3 days.
3 day,
Yeah.
a rolling 3 day.
For the power, for the temperature, that day is the vital one. Is really good with that.
Do you have a home weather station?
I do not. I have a rain gauge. One of the things I learned in looking at all this data is they're high maintenance, and I didn't want to spend time keeping my weather, so I just.
And you didn't want to spend $20,000 on that one that you noticed.
I did call one of the meteorologists that's still at TVA and say, can we access the Sequoia data? And they said, not anymore.
Oh.
Used to, but security reasons, they don't allow that anymore. Not even for retirees, I guess.
Is there a place on here that has a predicted PM2, like air particulate, or like for your area? There's some places like on
there
Windy
is.
and some other sites that have it, but
There is, I don't remember where it is right now. Yeah, I'm not sure where that is, but it should be there somewhere.
I'll look around.
Do they do just the United States, or do they do other locations around the world?
National Weather Service just does
Just as,
continental and Alaska and Hawaii.
Let's say visibility, what did we say, 10 miles is the limit. If you're standing on
static
top of
picture.
the mountain of Osage and you can see Big Frog Mountain all the way up. Even when they say visibility is bad, what are they basing? I mean, what,
They have a sensor at the airport at ground level.
they ground level?
Yes, at ground level it measures that. So if you're on a ridge, it could be a lot different. You may have fog at Chattanooga and not have fog on the ridge.
So when they say visibility, if you're on the mountain, it's 10 miles. At 10 miles, that's it. You can't see anything from that point on. So it's like being in a
You might be able
cloud
to see it, but it's not going to report it.
bank. Okay.
10's the
maximum-
max for the sensor.
Yes, the max on the sensor is 10 miles. In real life, it's going to be more than that sometimes. I think where that might be useful too is in the summertime where you've got haze. If you're starting to see it creep below 10 miles, then you can tell that the haze or smoke is getting pretty thick.
And I think I may have, we have the Astrospheric probe, which you probably didn't have access to when I said that. And I'm like, oh, I didn't tell you that.
Thanks,
We
bro.
have like, they combine, there's like 4 of the forecasts that you can look at and they have them colored.
Oh, okay.
And they say when they're all blue, then you can be guaranteed that.
Okay, very good.
Oh, that is important. As a club member, you can get the Astrospheric Pro for free. You just
Yeah, if
tell
y'all
us
don't
and
know it, if y'all don't know it, you can get, because you're a club member now, you can get Astrospheric Pro. And John Sadler, I think he's online, he's the one that says she loves.
And you don't even have to ask him, you just go to the app and you tell it that you're in our club, and then he'll get a
He'll approve it.
notification and approve it.
It also gives you jet stream.
Okay.
Atmosphere Pro.
Jet stream.
Yeah, it's on the BAS website.
Look at jet stream Barnard.
It's down at the bottom. So then look
It's
at it.
been a bit since we've made that announcement. I can't, so when you got your since you just joined, on the list of things, did it mention the Astrospheric app on your reply when you first joined? Did you see that? Or? I can't remember if it's on there or
Last time I looked at
not.
one of those emails, I think it's there.
But if you don't know, you can actually search Barnard Astronomical Society on there and put in for a request. And we have admins that get that response and we can accept it and get you that access to the pro version. So, yeah.
I have a question about like access to things as a new member. You mentioned that they were you mentioned that they are in like you guys make announcements in the app or whatever, and I'm not on there. So
Oh, for Groups IO and Discord?
in Discord, yeah, I'm not there. How do I get added to that?
There,
There are links on that.
there are links. Did you get the newest newsletter?
No,
Because you just joined.
like last month. I don't know, Beth, when did I?
So you should have gotten the latest newsletter. In the newsletter now, there is a link that takes you to a hidden website that is specifically for members only. And it has Groups IO, the information about Groups IO, information about Discord, how to get in there. So I really highly recommend that. Because if not, you're missing out.
I did get it.
Okay, and if you didn't, or you can also access it from our website now.
You gotta read it, though. That's the truth.
Well, that is, yeah. Okay.
Thank you.
Sorry that was
That's
a
fine.
good segue, so, yeah. Anything else? Doyle, thank you.
Yeah.